Today, we are also pleased to have Mr. John ALAMI taking part in this conversation online. He's professor of plasma and surface technology, head of materials science, energy and nano-engineering department, and holder of the energy sustainability chair at Mohammed VI Polytechnic University, UM6P, since 2016. Dr. ALAMI has a doctorate in plasma physics and a PhD in thin film physics from the University of Linköping in Sweden. Following postdoctoral research at Aachen University in Germany, he joined industry where he held the position of research and innovations manager. And in 2011, he founded and managed an R&D company and simultaneously occupied the position of adjunct professor for 3 years at the prestigious Shanghai Institute of Ceramics, Chinese Academy of Science. Dr. ALAMI has more than 130 peer-reviewed publications and 30 patents and patent applications. Such an exciting experience we will be digging into later on. Dr. John ALAMI, it's a pleasure to have you with us today.
Thank you very much, Zina, for the introduction, and good afternoon, everybody.
Thank you so much. So as an academic and manager of research, how do you see the role of a research university such as Mohammed VI Polytechnic University in addressing the challenges of climate change in Morocco and in Africa?
Thank you for the question, dear Zainab. Well, as I see it, and I think as both my panel colleagues already insinuated, the role of a university in addressing climate change challenges is actually multifaceted. This is quite well manifested at UM6P in several actions that aim to first foster various forms of research, including fundamental, applied, and industry research. To offer a range of education programs spanning undergraduate studies, engineering and research studies, and also considering that we have observed that forward-thinking universities, they typically are targeting entrepreneurship in their offerings as well. So UM6P aligns with this trend, as we believe it is a crucial approach to tackling climate change challenges. The complexity of these issues necessitates an environment that where innovation is deeply ingrained in the university's fabric, meaning that it is embedded in the programs, the culture, and also the identity of the university. So at UM6P, we focus and we follow a specific methodology. We initiate exercises that encourage stakeholders to engage in understanding the Moroccan context, which involves, of course, identifying strengths and weaknesses, determining Morocco's and ecosystem's position in the African and global context, and also identifying key partners and discerning the needs and challenges at hand. So, for instance, when addressing decarbonization, which is a critical aspect of climate change, we recognize that it is a complex endeavor that depends greatly on the scope considered for greenhouse gas emissions. So by leveraging multidisciplinary research and education programs, UM6P together with OCP Group, of course, and are addressing all scopes, 1, 2, and 3, greenhouse gas emissions to ensure carbon-free enterprise by 2040, as my colleague Nofel has mentioned. So I would like to also emphasize that these efforts involve a multidisciplinary collaborative approach driven by a clear vision and purpose, and the establishment of international partnerships and collaborations, including those within our own continent, Africa. So this allows us to finally engage in bridging the gap between industry and academia. So what I'm trying to say that it's necessary to establish the ground for those kind of collaborations, for those kind of partnerships, which is for us actually another priority, and helps us focus on developing innovative education and training programs for further enhancement of the impact of our endeavors. Thank you.
Thank you so much, Mr. ALAMI. With such ambitious objectives in diverse fields such as agriculture, water, and green energy, was wondering what are the specific actions that has taken UM6P to train adequate and impactful human capital capable of accompanying this energy transition?
Yeah, thank you. So when it comes to education and training, I'm constantly reflecting on the underlying goals and objectives, especially in fields as dynamic as climate change and green energy. So there are several reasons for this. First and foremost, it is the need for awareness. The ever-evolving changes and the challenges in our world, be it from climate change, the urgent demand for sustainable agricultural practices, or the rapid advancements in digitalization and AI, these all demand a continuous re-evaluation of our approach. In my view, educating the next generation of researchers and engineers should go beyond technical proficiency. We should take in consideration this ever-changing environment and the new different dimensions that need to be taken in consideration for an efficient education. So it should also, and research of course, so it should also encompass adaptation, innovation, and an entrepreneurial mindset. What it means at UM6P is that we are dedicated to crafting educational experience that reflects these principles. And I believe we are making significant progress. Our programs place a strong emphasis on multidisciplinarity, as well as what I refer to as power skills. Power skills, typically known as soft skills, but actually they're empowering our youngs through effective communication, leadership, augmented humanity, collective intelligence, and critical thinking. So having those elements in education programs are actually necessary for an efficient education of the future, and also for efficient research that is impactful and innovative. In fact, if we examine shortly the current job market, we recognize that it increasingly seeks experts who are not only technically proficient, but also capable of constant innovation and facing challenges head on, which of course includes a willingness to take risks and explore new solutions, as well as an ability to adapt quickly and to change. So it is clearly a shift in the traditional education paradigm, and I believe our success hinges on how urgently we address this educational imperative. What I described here is what I otherwise call the entrepreneurial mindset. And it is in this context that I would like to give my take on entrepreneurship, because typically people think of entrepreneurship as creation of startups, but I think it's more than that. Entrepreneurship embodies the actions, all actions that's taken by individuals or groups that unleash creativity and energy, ultimately leading to the creation of new economic, social, institutional, and cultural environments. So it's really a culture, a state of being, and this is the mindset we aim to install not only in our students, but also in our researchers, administrators, collaborators, and beyond. It's a commitment to adding value through the liberation of energy and the establishment of values that have the potential to drive change and make a meaningful impact. So witnessing young engineers and researchers that embrace this entrepreneurial spirit, working tirelessly with a clear sense of purpose towards making an impact, a real impact, is truly indescribable. I'm proud to say that at UM6P, this spirit is very much alive and thriving. It serves as a continuous source of motivation and hope, not just for me personally, but for our stakeholders, and particularly for OCP, Innovex, and all other partners that we are working with.
Thank you so
Thank you.
much, Mr. Jones Alami. I'm proud to say, too, that through the different presentations, we've seen some of the main ingredients necessary to accelerate the transition to high-yield, climate-positive agriculture to combat climate change and enhance food security. Today, OCP is investing in new industrial capabilities, talent pool, cutting-edge soil health science, tech innovation, collaboration, and financial partnerships to make possible the transition to climate-positive agriculture and decarbonize its own value chain. Now, I want to take time to acknowledge our dear audience once again and to thank you all for being with us here. We are going to take maybe some questions from you. Don't hesitate if you have any question. Yes, please.
First of all, thank you very much.
Here is the mic.
Okay, thank you very much for a very, very interesting presentation. I have a quick question in relationship to advances in technologies, which I believe could be an additional advantage to the way fertilizers interact with the soil, and I'm thinking specifically of nanotechnologies. My understanding is that in recent years, or maybe even decades, I don't know when the process started, but with the development of nanotechnologies, there are now possibilities to actually develop molecules at a nano level that are much better absorbed by the plants, so they give better produce, not only in terms of quantity, but also in terms of quality. And at the same time, because they are much smaller and better absorbed, not only do you need less quantity, which will contribute to decarbonization by default because the production would be reduced, but also increase the quality of the soil because more is absorbed and less is left in the soil that, as you know, fertilizers, when they're heavily used, damage the soil on the long term. So I was wondering what OCP has been doing in that field, if anything, and what are the prospects in the coming years? Thank you very much.
Dr. Jones, maybe the question is intended to you.
Okay.
Thank you so much.
For the question. I'll try to answer it, although I'm not an agriculture person, but I work with nanotechnology. And I think what nanotechnology allows us to do is to understand the micro level, the molecular level interactions between the different elements. For example, what happens at the surface of a seed when it's generating, what happens when it's in the soil, what kind of chemical reactions are taking place when they are being sowed. And I think the understanding of these mechanisms at the molecular level allows us to understand the interactions, as I mentioned, and then allows us also to make better choices when it comes to seeds, seed engineering, seed enhancement as well, to understand what kind of soils, for example, if we at the nano level know exactly what kind of elements are active in a soil, which ones are not so active, destructive, probably need to be eliminated. How can we engineer, for example, our fertilizers to play a role in making those soils much more efficient in feeding the seed that we put in? So you see that nanotechnology at every level of agriculture can be used to enhance the productivity and the quality of agriculture. I hope I answered your question.
So maybe I should just add a little bit to that. So OCP has been revolutioning their way of doing fertilizers. So they went into MAP and like NPKs, TT, and I mean it's several descendants and fertilizer families that are close to what you just described. It's true that today we do not have the person with the knowledge to answer specifically your question. But indeed, our agri business line is definitely looking into new technology fertilizers and trying to revolution the way we produce fertilizers. So if you're interested, we can get your contact and send you more information.
Definitely. Thank you, Ms. Zawaf. Do you want to ask, is there any other question in the room? Yes, please.
Thank you for the presentation. Well, considering OCP that's 30% or so of the world phosphate fertilizer production, which is impressive. Have you had meetings with your competitors in sense to get them to do some of the same green initiatives that you're doing? You know, because there's nothing really, you know, secret in a sense, but it's good for everyone if they can follow the same things that you're doing.
Maybe do you want me to answer this question?
Okay, please go ahead, Nofel. Thank you so much.
Yeah. Well, of course, we are part of many sectorial associations, either the International Fertilizer Association, where we have conducted with our peers from Norway, from Canada, from Middle East, all our peers, we have conducted studies with the experts and to recommend how we could mitigate and decrease or abate the emissions linked to fertilizers for production, but especially for the use at the farmer level, because we would succeed only if we give positive or a positive business plan or model to the farmer. We cannot make the farmer carry the burden of the decarbonization. We have to empower the farmer, bring the finance, and bring the technology to that. So we have even produced a document for our positions that was released for the COP27. And we are continuing this effort. We're also doing it also for South countries in the South-to-South cooperation. We are part of the Arab Fertilizer Associations. And we have even been awarded in October the prize of the most sustainable fertilizer company in the Arab world by the Arab Fertilizer Association. But the meaning of that is not to get the prize, is to share, and to set the objective for all the sectors. And we are happy to see that other companies joining the SBT's science-based target initiatives, and also from the South companies, some companies more and more conscious of innovation and sustainability for contributing to the climate change mitigation.
Thank you so much, Mr. Mahdar. Yes, more questions by here.
Good afternoon. Niels Schultz, I'm from UNIDO, from the Agro Innovation and Bioeconomy Unit. Thank you very much for the presentation. That is very interesting to see as we are all talking about getting regenerative agriculture to scale and to address this food, energy, water system interconnectedness. There are two aspects of technology that I would be interested in, to what extent you're using it already or integrating it in your portfolio, and one of that is mycorrhizal inoculation, as this is one pathway to make phosphates better plant available. And the second complex would refer to pyrogenic carbon and biochar, to what extent you're integrating that as well, as this is energy related and climate.
Thank you so much, sir. I don't know if Dr. ALAMI has some information about that.
Not really. I know that there are projects in the use of biochar for regenerative agriculture, for regenerative soil, but I don't have any details on that. Maybe Nofel can chip in.
Oh, we are working on biochar and biomass in general, and we have not only biochar but biomass in general. We are looking at how to integrate that in our operations. We have many labs, including with the University of Mathematics, not with the Professor Yunus, but with the Texel centers on looking at how to do the gasification, etc. But anyway, to integrate that into complex processes of drying, and we are looking at how to integrate that, but nothing yet at the execution level. But we have pilots ongoing.
Okay, thank you so much. I saw another hand maybe, or it's maybe time to wrap up? Yes, of course.
Thank you, Madame Jalloun, and thank you for all the presentations. Actually, I have two questions. The first one, I think Dr. Alami mentioned the multi-stakeholder partnership. OCP recently signed a certain number of partnership agreement recently with IFC, with the African Development Bank. You joined recently the World Economic Forum. I wanted just to know which kind of collaboration we have with the international institution. Second question, I was impressed actually by the decarbonization roadmap, and OCP is operating in an ecosystem when you have a certain number of partners, including subcontractors. What you are doing actually to make sure also that your subcontractors are respecting, the same standards in terms of sustainability. Thank you.
Thank you so much, Ms. Hanzaz. Nofel, maybe you're smiling. Those last questions are for you.
I think you can answer some of them, but concerning international corporations such as IFC, which is part of the World Bank, we are very proud of the cooperation with them, and what it is telling, IFC, when they sign partnerships, they audit a lot of the green part of it, and not only the green part, the social part, the human rights part, and that's why we are proud of it. And we see the cooperation with IFC as a very long-term and serving also our sustainability social agenda. And we have signed for water projects as part of resilience and adaptation. We have signed for $100 million. We have signed another $100 million for the solar projects to achieve our objective of 100% electricity green. And all these organizations, and we have two more projects to come that will be announced with IFC. Big financing projects that will be these for COP28 that are planned to be communicated in COP28. We are also part of WBCSD. We are part of the World Economic Forum, etc. But we are part of these organizations to communicate the voice of the South, the voice of Africa, and to show that Africa is not only a receptacle to receive recommendations, technologies, but also Africa and can set the standard and can be a leader and can get the best grades, best investments, but also to voice our particularities, our constraints, and on technologies, and also on our industry, phosphate-based, that is not fertilizer that are not well known, and sometimes we see the standards that are made are not very adapted to that, and we need to sit at the table with those standard makers to make the objectives ambitious, but also achievable. And that was the first question. The second question, sorry, it was about decarbonization.
And about subcontractors.
Subcontractors.
Yeah, exactly.
What is, we are engaged, yes, in a big project that is also mandatory with the SBTi and CDP on supplier and value chain engagement. So we have engaging with many suppliers and clients to first, thanks for transparency, to give us the data and to see what is how much carbon they are generating with their operations, and also to sensibilize our clients to their carbon footprint and environmental footprint. And this is a long journey. We are now at selection of our collection of all the data from them, and what we discovered is that 98% of our footprint for supply chain is coming from two things, from ammonia and sulfur. That makes things complicated, but makes things also easier, because 80% of our raw material supply is coming from ammonia. And this is, we will be turning it around completely with our projects of integrating green ammonia into our projects. So this big footprint would be completely abated. For sulfur, we are engaged with our suppliers as well, because it's 1/6 or 1/5 of our ammonia footprint, the sulfur, and we're engaged as well how to see which regions are bringing the low-level sulfur. And the same thing, we are doing it also with our subcontractors in Morocco. But our particularity is we have two raw materials that constitute the biggest part of our footprint.
Thank you so much, Naufel. As I mentioned before, OCP Group is actively working on simultaneously accelerating the two SDGs, Zero Hunger and Climate Action. But SDG 17 is the key to be able to achieve such ambition. So the right partnerships. And we are working to have the right partners to join forces and be able to achieve such huge ambition through all the different international institutions and the partners that have been mentioned before. So if I think it's time to close the session, it was really a great and wonderful session. Thank you for spending your most valuable, I will say, and precious asset, which is time, your time. It's time to thank our speakers for participating and making this session really great. Please join me in giving them a round of applause for their valuable contribution. So let's please do. Of course, again, thank you everyone, the organizers, the speakers, the audience. We'll say congratulations for the success of this great forum, the International Vienna Energy and Climate Forum. Special thanks to UNIDO, and keep well. And this concludes our session. Thank you so much.